What's going on, guys? Professor Bryant back with another installment, Workout Wednesday. We're still on solids, looking at another example of a metal unit cell problem. In this particular example from the text, it says that aluminum metal crystallizes in a face center cubic unit cell. How many atoms are in a unit cell? B says what is the coordination number of each aluminum atom? And then estimate the length of the unit cell. A, the edge A from the atomic radius of aluminum, which is 1.43 angstroms, and from that determine the density. So we got to do a couple things here. All right. First, from the conceptual standpoint, again, this is question number 39. We're working with a face center cubic aluminum, right? And face center cubic aluminum has 4 atoms in the unit cell, and the coordination number, this is A, coordination number is 12, okay? There are 12 atoms that one atom touches on each side, right? Or all the way around in 360 degrees. Remember, in a face center cubic, we're dealing with a situation where all of the atoms touch one another. And again, my drawing is not great, but if the dots represent the center of each of these 4 atoms, and then we look at that in the cubic arrangement, the middle one is going to touch 12 things. It's going to touch 4, 8, and 12 on each side, right? 4 around it, 4 to the on one side, and then 4 on the front side. Again, best thing to do is look at the visualizations and the links that I sent, because again, my 3-dimensional artistry is not great at all. Okay, so there are 12 atoms that is touching. The length of the edge of the unit cell A, which is question C, can be determined if we think about the unit cell, and I'm going to try to draw this one a little bit better. The distance across the unit cell face is equal to 4r, right? That distance is equal to 4r. What that means is that 4r squared is equal to length A squared plus A squared, right? Pythagorean's theorem. All I'm using is Pythagorean's theorem here to determine the length across. Again, this is 4r because the radius of the sphere is inside the unit cell here on each corner, and then the whole radius is across that face because half of the atom is in the unit cell when it is on the face. Okay, so what that means is they want us to estimate the edge using the radius value that is equal to 1.43 angstroms. So we can solve this equation essentially for a squared, right? So what we end up getting is 2a squared equals 4r squared. We end up seeing that a squared is equal to 4r squared over 2. And we end up seeing that therefore then a is equal to square root of 4r squared over 2, which is equal to 4r over square root of 2. Okay? So a edge length can be plugged into the calculator and determined to be 4 times 1.43 divided by square root of 2 is equal to 4.04 angstroms. And I'll put that up here too, 4.04 angstroms. So that is edge length A. Okay? So part D wants us to calculate the density. Okay? So I'm going to put D over here. Remember, density is equal to mass over volume, and to find mass, we need to utilize the structure, which is face center cubic, knowing that there are 4 atoms in the cell and the molar mass of aluminum. So to get the mass is equal to 4 atoms times 1 mole over Avogadro's number times the molar mass of aluminum, which is 26.98 grams. Okay? Here. All right. So this is the dimensional analysis to get the mass. So mass is going to be in grams, and it's going to be equal to 4 times 26.98 divided by 6.02 e to the 23rd. So here we're dealing with 1.79 times 10 to the negative 22 grams. So that's half of the equation, right? We solve for mass. How do we get there? Number of atoms is most important because of the structure. Divided by Avogadro's number times the molar mass. So we know how much mass of aluminum is in the unit cell. Now, to determine volume, V is equal to A cubed, right? Since this is cubic, length times width times height is going to give us the volume of our cube. But I would suggest converting this into centimeters first. So convert angstroms into centimeters, and we do that via dimensional analysis. Remember that 1 angstrom is 1 times 10 to the negative 10 meters, and then 1 meter is 1 times 10 to the positive 2 centimeters, and then we end up with 4.04 times 10 to the negative 8 angstroms is going to be 4 times 10 to the negative 8 centimeters. So we can use this value here, 4.04 times 10 to the negative 8 centimeters cubed, and the volume in this case, and I'm going to make a divisional separation here. The volume in this case is 4.04 e to the negative 8 raised to 3. We're dealing with 6.59 times 10 to the negative 23 centimeters cubed. So to get density, which is what we've been asked for, density is equal to the mass, 1.79 times 10 to the negative 22 grams, all over 6.59 times 10 to the negative 23 centimeters cubed. And we have now solved for the density, 1.79 e to the negative 22 divided by second answer. And we see that it's 2.71 grams per centimeter cubed, right? So we have the density by just knowing structure and atomic radius, which will give us volume, and from there we can use all the rest of our techniques. Okay, again, that is it for question number 39, Workout Wednesday. If you have any questions, feel free to leave a comment or email.